In object-oriented software engineering, we are going to discuss about object-oriented design to implementation. In that, the first one we are going to discuss about the activity diagrams, which will be very much helpful for the design before. In object-oriented design to implementation, modeling dynamic behavior of a system allows to represent, visualize, depict, and document the changing parts of the system. The behavior of the operations and state of the objects may be modeled using activity diagrams and state chart diagrams before starting the implementation. So the two diagrams which are mainly useful for the implementation are the activity diagrams and state chart diagrams. The intermediate step will help to bridge the gap between design and implementation. The states of the objects are depicted along with inputs and outputs produced based on these inputs. UML diagrams that model dynamic parts of the system are activity diagrams and state chart diagrams. The activity diagram models a sequence of steps followed by a process or operation. In the state chart diagram, the various states through which an object goes through during its life cycle are depicted. The implementation transforms the detailed design into a source code, which is achieved by a group or team of developers. Then first we will discuss about the activity diagrams. The dynamic aspects of a system are modeled through activity diagrams. Activity diagrams enable to visualize, understand and document the flow of activities in an operation or a process. In table 7.1, the symbols which are used for the activity diagram are given. The rounded rectangle which is representing the activity, then the transition which is going to be represented by an arrow, and the third one is the start symbol, and fourth one is the stop symbol, and then branching is used to represent an if else condition with the got condition in square brackets. And next one is a fork, which breaks up an activity into a set of concurrent sub-activities. And join is used to combine the flow of concurrent activities into the next a single activity. So activity diagrams have many applications and they are increasing the understanding of a business model, a process or a use case, determine the objective for business related e-commerce applications, simplify a given operation. Then activities and transitions. An activity represents execution of a step or a set of steps in a process or an operation. The activity may be atomic or may consist of multiple steps. An activity, either manual or automated, is used to complete a given task. Transition represents the path from one activity to another activity. An activity is represented by an oval shaped circle with rounded ends, and a transition is represented by a directed line. So, in the figure 7.1, activities and transitions subtracting two numbers are input value of variable A and inputting the value of variable B, then C is equal to A minus B, then value of C will be displayed. The next is a branching. Branching is used for making decisions in an activity diagram. Similar to a flowchart, a Boolean expression God condition, that is God condition, depicted in brackets is used to take decision about which alternative path to follow. The decision branch is represented by a diamond with one incoming transition and more than one outgoing transition. So in the figure 7.2, the branching which is represented here, so we are inputting the value of A and B, and in if A less than B, then C is equal to B minus A will be evaluated. If A greater than B, then C is equal to A minus B will be evaluated, and then we are going to display the value of C. The next is the modeling concurrency. In UML, concurrent flows are depicted by synchronization bars to represent fork and join of parallel activities. A fork divides the activities into two or more concurrent sub-activities. The fork may consist of one incoming transition and more than one outgoing transition. A join combines two or more concurrent flows when they are completed. A join may have more than one incoming transaction and one outgoing transition. Each fork should have a join. So here in figure 7.3, the modeling concurrent activity activities which are represented as we are inputting the value of A and B, and which will be um, divided into concurrent activities, that is addition, subtraction and multiplication, and finally the output will be displayed. The next is using swim lanes. A swim lane groups all the activities that are carried out by the owner of the swim lane. The transitions may cross between entities in a swim lane, and each swim lane is represented by a unique name. For example, in figure 7.4, the swim lane which is represented, for that swim lane, there are three in the system which is consisting of three swim lanes. Those are the manager, system, and the printer. The activities residing in the swim lane show the activities for which the manager is responsible. The manager who is responsible for entering the data. And then next one is the system swim lane. And here the system is responsible for that. The system generates a requested report. Similarly, for the third case, the printer is responsible and the printer prints the reports generated by the system. In an activity diagram, objects may represent the changes in the object because of an activity. Example, the issue book activity changes the state of a book object to closed for issue. The objects can be connected to an activity through dotted directed lines. So that is represented in figure 1.5 where the object flow which is represented. The uses of activity diagrams for modeling a workflow or process. That is the first use. There are many business processes that consist of activities that need to be followed throughout the process. The following steps may be carried out to model a workflow or a process, which is represented as determine the business entities, identify the initial states with its preconditions and final state with its post condition, specify the activities that will take place, provide a separate activity diagram for each complete activity, then identify decisions and concurrent flows, then show the changing values of objects in the activity diagram. E-commerce application, the swim lane diagram 7.6, that activity diagram which is represented where we have the customer, vendor, payment gateway, credit card company and warehouse, and the activities of each and every swim lane which is represented clearly in the diagram. For example, for vendor, it is receiving an order and confirms the order. These are the two of the activities of a vendor. Similarly, when we'll go for a customer, he has to select the items and adds a item to the shopping cart, and he has to place the order, and he has to provide the credit card details. Finally, he has to receive the item after payment. Similarly, we have the activities for payment gateway, credit card company, and warehouse. Then second use to model a use case. Each use case represents functionality of the system. The flow of the use cases can be depicted by using the activity diagram. So the activity diagram is represented in the figure 7.7, that is activity diagram of maintain book details. So maintaining the book details, we have to add book, delete book, update book and view book. So these four are the activities. So to create an activity diagram of a use case, the following steps to be followed. Just identify the preconditions and post conditions of the use case as given in the use case diagram. Identify the beginning of the use case. Identify the activity that will take place in the use case. Then keep the activities simple and understandable. So here the example which already which is explained here for maintaining the book details as shown in figure 7.7. Then third uses to model an operation. An activity diagram can be created for an operation. So the following steps should be followed to model an operation. That is, identify the parameters and return the value of an operation. Identify preconditions and post conditions of an operation. Determine the detailed set of activities that may take place in an operation. If necessary, use branching to represent the conditions. So this is represented in the figure 7.8, that is activity diagram for issue book operation. So here we are retrieving the current date. If the member is a student, the expected date of return is from the current date plus 15 days. And if the member is a faculty or an employee, the expected date of return is the current date plus 30. Then we can save the transactions. So for a particular operation, the activity diagram which is depicted in figure 7.8. Thank you.